Welcome back, everyone. Today we are tackling a massive concept in programming, asynchronous programming using Python's Asyncio library. Imagine you are at a coffee shop. If the cashier takes your order, makes your coffee, and refuses to help anyone else until your cup is ready, that is synchronous programming, and it is painfully slow. Let's see how Python solves this. In regular or synchronous code, Python executes tasks one by one like a strict checklist. If line 2 takes 5 seconds to download a web page, your entire program freezes until it finishes. Asynchronous programming lets Python juggle multiple tasks. While one task is waiting for data, Python jumps to another task, keeping everything moving efficiently without idling. At the heart of Asyncio is something called the event loop. Think of the event loop as an efficient air traffic controller or a manager at a restaurant. It constantly monitors all your tasks, checks which ones are ready to run, pauses the ones that are waiting for a response, and switches to another active task instantly. To write asynchronous code in Python, we use two special keywords: async and await. When you define a function with async def, you are telling Python, hey, this is a special function that can be paused and resumed. It's called a coroutine. Let's look at how we write our very first coroutine. Let's write a simple function. Instead of def my_func, we write async def my_func. If we try to run this function normally like my_func, Python won't execute it right away. Instead, it returns a coroutine object. It's like buying a movie ticket. You have the ticket, but the movie hasn't started playing yet. To simulate a delay, like waiting for a network request or downloading a file, we can't use Python's normal time.sleep because that blocks the entire thread. Instead, we use await asyncio.sleep 1. The await keyword tells Python, I am going to wait for 1 second, feel free to do other work in the meantime. How do we actually start our coroutine and run the event loop? Python gives us a very convenient helper function called asyncio.run. You pass your main coroutine into asyncio.run main, and Python sets up the event loop, executes your async functions, and cleanly shuts down everything when it's done. Let's jump into our code editor and build a small script together. First, we type import asyncio. Next, we define an async function called main. Inside main, we will print a start message, use await asyncio.sleep 2 to simulate a 2-second delay, and then print an end message. Let's see what happens when we run it. Now, what if we have multiple tasks? Let's create a function called fetch_data id delay that simulates downloading data with a delay. If we call them one after another using await, they will run one by one. But wait, if they run one by one, we haven't gained any speed yet. Let's look at how we run them concurrently. To run multiple asynchronous tasks at the exact same time, Python provides asyncio.gather. You can pass multiple coroutine calls into gather. Python's event loop will kick off all of them concurrently, wait for all of them to finish, and return a neat list of results. This is where asynchronous programming shines. Let's look at the code screen here. We have 3 tasks taking 1, 2, and 3 seconds respectively. If this were synchronous code, it would take 1 plus 2 plus 3 is equal to 6 seconds total. But with asyncio.gather, fetch 1, fetch 2, fetch 3, the total execution time drops to just the maximum duration, only 3 seconds. Look at how powerful that is. As beginners, it's very common to make a couple of mistakes. First, Forgetting the await keyword before calling an async function Python will throw a runtime warning because the coroutine was never awaited. Second, mixing up standard blocking libraries like requests with Asyncio. Remember, if a library isn't async native, it can still block your event loop. Is async good for everything? Absolutely not. Asynchronous programming is brilliant for I/O-bound tasks like downloading websites, reading, writing files, querying databases, or handling chat server messages where your program spends most of its time waiting. If you are doing heavy mathematical computations or number crunching, standard synchronous code or multiprocessing is still your best friend. Let's do a quick 1-minute challenge right now. Pause the video and try writing a script with 2 async functions, one that waits for 1 second and prints the task A finished, and another that waits for 2 seconds and prints the task B finished. Use asyncio.gather to run them together. Take 60 seconds to try it out in your editor. Fantastic job today, everyone! Let's summarize. We learned that Asyncio helps Python handle waiting tasks efficiently without freezing. We discovered the event loop, practiced writing coroutines using async and await, and ran multiple tasks concurrently using asyncio.gather. Tomorrow on day 58, we will take this further and build a real async web scraper. See you then.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.